Many of y'all are probably familiar with the term evolution, and some of y'all, I'm guessing, are also familiar with the term natural selection, although it isn't used quite as much as evolution. And what we're going to do in this video is see how these are connected, but we're also going to address some potential misconceptions that folks have about evolution. So when a lot of people think of evolution, they think of a diagram or an image that looks something like this. They can see what they would consider to be a more primitive ancestor evolving into a more sophisticated, a more modern type of organism. And this is going from some type of primitive ape all the way to human beings. Now, there's some aspects of this diagram that give the right idea, that evolution is the phenomenon, that organisms over time can evolve, can change in their traits, that can actually become different species. Now, the one thing about this diagram that might be misleading is calling this character primitive and somehow imagining that this one in the front is better or more advanced. Evolution doesn't necessarily go from good to bad or primitive to advanced. It's really just continual change based on what is most suitable for the environment in which the organisms are in. And this can take millions of years. For example, the common ancestor of human beings and other apes like chimpanzees or gorillas can be 5, 10 million plus years in the past. But it can also happen right before our eyes. For example, every year we have a new flu virus because the flu virus is constantly evolving through mutation. We have the coronavirus, and we're having new variants of that, it seems like almost every few months. That is evolution happening right before our eyes. But the key question is, how does this actually happen? Does the DNA know to change into something else? Well, clearly not. The DNA is not sentient. It is not somehow constructing itself. And that's where natural selection comes into the picture. So let's imagine a population, and I'm going to think about a very abstract population of these little circle-shaped things. And an important characteristic for evolution to happen is that you need variation in the population. And we talk about variation, we're talking about different expressed traits. And you might ask, where does that variation actually come from? Well, it's going to come from mutation. I talked about variation when we think about viruses, the flu virus or the coronavirus. And it can also come from sexual reproduction. And we go into a lot of detail in other videos how sexual reproduction mixes and matches all of the potential alleles that are in a population so that different members of the population are getting different combinations of those alleles. And so that contributes to variation. And now variation by itself does not lead to evolution. You need variation and selection pressure. And this is really where the term natural selection is coming from. What do I mean by selection pressure? Well, in this little example here, if these circles and triangle-looking things could just keep reproducing, they could find as many resources as they need, there's no shortage of food, there's no shortage of environments in which they can live and reproduce, they had no predators, well, you're not going to have selection pressure. And so all of these variations might have an equal chance of living their life and then reproducing. But now let's introduce some selection pressure and imagine what might happen. Let's say we introduce the selection pressure of a predator that has a much easier time seeing white. Well, then what's going to happen? Well, over time, generation to generation, the white circles and triangles here are going to be much more likely to be eaten by that predator before they can reproduce and pass on the allele or the alleles that might result in this white trait. And so next generations or future generations are going to have fewer and fewer of these white shapes. So the next generation might look a lot like this. A lot more of the purple we're seeing, and a lot more of the blue. Now, on the other hand, you could have a scenario where instead of a predator that sees white and can't see the other color showing up, where there's a shortage of food. So that's another form of selection pressure. Let's say a more triangular shape is useful for finding food. Well, then what's going to happen? Well, generation by generation, the shapes that are more triangular are going to have a better chance of surviving and reproducing. And so maybe in the first generation, you have maybe something like that does reasonably well, something like that could do very well, something like that would do well, Something like this could do well. But we're going to see, we might see a few of the circles still. We might see a few of these characters, but we'll see fewer of them. And we're going to see more of these characters right over here. And now you can imagine if this environmental pressure continues, then over generation and generation, you keep selecting for more triangular. If you go forward many hundreds or thousands or hundreds of thousands or millions of years, you might see some subset of this population that lives in this environment. They might have a very triangular shape. They might not even look anything like their ancestors. Now, does this mean that this shape right over here is somehow more advanced or better than what their ancestors saw? Or maybe there's a cousin species that was where the predators see white and the triangular shape really doesn't help you, and so they have a cousin species that looks like this. There's no way of saying that this species is more advanced or better than this species, but what we can say is it is more fit for its environment, and this species is more fit in its environment. So I will leave you there. And it's important to realize this isn't some magical process. It's all due to variation caused by mutation and sexual reproduction, selection pressure, and then that change happens over time. And this isn't just something that happens over millions or tens of millions of years. It happens before our eyes every day when we talk about the different flu strain or a different coronavirus strain or drug-resistant bacteria. It's very relevant to our day-to-day lives.